Okay, in our video series of ECG interpretation made easy, in this video we are going to talk about the rhythm determination. Rhythm determination has four main components. You calculate the rate, you check the regularity, you assess the P wave, you calculate the PR interval, and you assess the QRS complex, and then you write down a comment, an interpretation of the ECG. In my previous video, I talked about how to calculate rate, how to assess regularity of ECG rhythm. Now in this video, I'll be discussing the abnormalities in P waves, the PR interval calculation, and how to assess a QRS complex. At the end of this video, we'll be solving some very important and high yield ECGs. Now coming to P wave, a P wave should be round, upright and uniform. Remember, when an ECG strip is given to you, you must see that whether the P wave is uniform, round and or the P waves married to the QRS complexes or not. Now what does that mean? P waves should be followed by a QRS complex. Always look for a QRS complex after a P wave. If after a P wave QRS complex is absent, it is abnormal. Normally when the atria contract, you see a P wave and the signal from atria travels to the ventricle and then the ventricles contract and you see a QRS complex. Now if after a P wave the QRS complex is absent, it means that the signal is not traveling from the atria to ventricles and there is a block. So you must always look that are the P waves married to QRS complexes or not, or the QRS complexes following P wave or not. And you have to see, is the duration of P wave less than or equal to 0.10 seconds. Normal P wave is less than or equal to 0.10 seconds. Now remember, a small box on ECG is equal to 0.04 seconds. And a P wave should normally have almost two small boxes in it. That is a normal P wave, round, upright and married to QRS complex. That is a normal P wave. Now this is a P wave. If you look at this P wave, this is round, this is upright, and if you see there are almost 1.5 small box, so it is normal. It is less than 0.10 seconds. That is a normal P wave. Now if you look at this ECG, in this ECG you can see the P wave is normal, round and upright, and it is followed by QRS complex. It is married to the QRS complex. After each P wave you see a QRS complex. And if you look at the number of small boxes, it almost has 1.5 small box. So it means each small box is 0.04 seconds and 1.5 small box is 0.06 seconds. So it is less than 0.10 seconds. It's normal P wave. Now coming to PR interval. PR interval begins from the start of P wave to the start of R wave. That is the PR interval. Remember, interval has the waves and lines in it. Segment on the other hand is only the line. If someone talks to you about PR segment, segment starts from here and it ends over here. And PR interval starts from the start of P wave to the start of R wave. That is the PR interval. Now PR interval has a normal length of 0.12 to 0.20 seconds. A small box is equal to 0.04 seconds. So 0.12 second is almost 3 small boxes. 3 to 5 small boxes size is a normal PR interval. And if PR interval is prolonged, what it means is that when the atria are contracting, you see a P wave, but it is taking a long time for the signal to travel from atria to the ventricles. Therefore, you see prolongation of PR interval. If the PR interval is more than 5 small boxes, it means it is taking a longer time for the signal to travel from atria to the ventricles and there is a block. So that is the significance of understanding the PR interval. You see that is the PR interval normal, whether the PR interval is between 3 to 5 small boxes or not, and is it constant in duration. You look at all the PR intervals, that all the PR intervals are the same, all the PR intervals are constant. One PR interval is not bigger or smaller than the other one. If one PR interval is smaller and other one is bigger, that's also a pathology. So they should all be constant. PR interval should be from 3 to 5 small boxes. This is the PR interval. Now if you look at this ECG, in this ECG you can see this is the P wave and this is the Q wave. So from here to here, this is the PR interval, and if you count the number of small boxes, it is 1, 2, 3, 4. So 4 small boxes is a normal PR interval. And if you look at the other PR intervals, they are all of the same size, 4 small boxes. So it's normal PR interval. 4 small boxes, 4 small boxes. Now, if you look at this PR interval, in this PR interval, if you this starts from the start of P wave to the start of R wave. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, almost 10 small boxes. So what it means is that from the time of atrial depolarization, it is taking a very long time for the signal to travel from atria to the ventricles. Therefore, you see a delay in QRS complex. Therefore, this ECG shows heart block. This is an ECG of heart block. Now, what you should do is you should pause this video right now and solve this ECG. Solve it yourself so that you learn and always remember this point. Now, coming to the answer of this ECG, if you look at this ECG from the start of PR interval to the start of R wave, there are so many small boxes, 1, 2, 3, 4, 5, 6, 7, 8, almost 8 small boxes are there, which is a prolonged PR interval. This is a first degree heart block. This PR interval is increased. It is taking a longer duration of time for the signal to travel from atria to the ventricles. Now coming to QRS complex, a normal QRS complex is narrow, it has steep angles and sharp points. That is a normal QRS complex. Now what is a narrow QRS complex? Normally, when you look at a QRS complex, the number of small boxes should be less than 3. Each small boxes is equal to 0.04 seconds. So 0.04 multiplied by 3 is 0.12 seconds. So our target is that the QRS complex should be having less than 3 boxes. That is a normal QRS complex because it is a narrow QRS complex. Now if you look at this ECG, you can easily see that the number of small boxes is less than 3. So it is a normal QRS complex. There is only one small box present in this QRS complex. So it is a narrow with steep angles and sharp points. It is a normal QRS complex. Now if you look at this ECG, in this ECG, if you calculate the number of small boxes between the QRS complexes, there are a lot of QRS complexes over here. This ECG is showing ventricular tachycardia. The QRS complex is wide. The QRS complex is not having sharp angles. The QRS complex is not having steep points. This is an abnormal QRS complex, a wide QRS complex. We'll go into these ECGs in detail, but let's build the basic concepts now. Now if you look at this ECG is also showing wide QRS complexes with large number of small boxes in between them. This is an ECG of monomorphic ventricular tachycardia, an abnormal QRS complex. Now let's solve this ECG. In this ECG, first of all, we will calculate heart rate. I have talked about different methods of heart rate calculation in my previous video. You can check out the link given in the description below. In that video, I have also talked about how to calculate heart rate in an irregular ECG by 6-second method. Now coming to heart rate calculation in this ECG. Now if we have one large box between the two QRS complexes, the heart rate is 300 beats per minute. If we have two large boxes between the QRS complexes, that is 150. And if we have 3 large boxes between the QRS complexes, that is 100. And if we have in this ECG, we have almost 2/3 of the third box as well. So we'll give it a rate of 80 beats per minute. Now if you look at the distance between each QRS complex, the distance between each QRS complex is equal. So it is a regular ECG. The regularity is regular. If the distance between QRS complexes is unequal or different, that is an irregular ECG. Now coming to P wave, the P wave is round, upright and married to QRS complexes. Each P wave is followed by QRS complex, so it is normal, married to QRS complex. Now let's look at the PR interval. In the PR interval, number of small boxes are 1, 2, 3, 4. 4 into 0.04 is 0.16 second. Now let's look at the QRS complex. The QRS complex is sharp, steep angles and one small box wide, that is a normal QRS complex, 0.04 seconds, narrow and sharp angle. So we will call it a sinus rhythm. Sinus rhythm is a rhythm which is run by SA node, where the P wave is normal and it is followed by a QRS complex. Now what you should do is that you should pause the video, take a piece of paper and a pencil and solve this ECG. If you don't solve these ECGs, you won't remember anything. ECG subject is very volatile. You will keep coming back to the videos, but you won't learn anything if you don't solve these ECGs yourself. Pause this video and solve it yourself. Now let's calculate the heart rate of this ECG. So between the QRS complexes, we have 1, 2, 3, 4 and almost 5 boxes, 300, 150, 100, 75, 60 beats per minute. But if you look at this ECG is having a variable RR interval. The RR interval over here is bigger and RR interval over here is smaller. So there is a difference in the size of RR interval. So it is an irregular ECG. It is not a regular ECG. In irregular ECG, one thing is for the calculation of heart rate, you can apply 6-second method. I've talked about 6-second method in my previous video. Another thing that you can do is that you can give a range of heart rate. What you do is that you calculate the smallest RR interval and calculate the rate. In the smallest, it's almost 70 beats. And you also calculate the longest RR interval and you calculate the heart rate. So over here it's 60 and over here it's 70. So you give it a range. You give it a range of 60 to 70 beats per minute. That's another thing that you can do in an irregular rhythm for calculation of heart rate. You give a certain range that the heart rate is ranging in between this. This is an irregular rhythm. If you look at the P wave is round, upright, and P waves has almost two small boxes. So it is married to QRS complexes. It is P wave is followed by QRS complexes. It is normal. It is married to QRS complexes. Now, if you look at the PR interval, we have almost 1, 2, 3, 4. Almost 4 small boxes. 4 into 0.04 is 0.16 seconds. So 3 to 5 small boxes is normal PR interval. Now, if you look at the QRS complexes, we have 1, 2 and almost 3.5. So 0.12 seconds. The angles are steep. There are sharp points. So it's a normal QRS complex. So the interpretation of this ECG is also a sinus rhythm, but it is irregular. You must mention that. Now, pause the video and solve this ECG. Now let's solve this ECG. If you calculate the heart rate in this ECG, we have 1, 2, 3, 4, slightly more than 4. So the heart rate is 70 beats per minute and it is a regular ECG because the distance between RR interval is normal. Looking at the P wave, we have round upright P wave with 2 small boxes. So it is normal and it is married to QRS complex because it is followed by QRS complex. Let's look at the PR interval 1, 2, 3, 4. So we have 0.16 seconds of PR interval. Looking at the QRS complexes, it is sharp, it is narrow, it is pointed angles, 0.08 seconds. The interpretation is a sinus rhythm. Now let's look at this ECG. Pause the video and solve this ECG yourself. Coming to the answers, so we have a heart rate of 1, 2, 3. So we have almost a heart rate of 300, 150, 100 beats per minute. The RR interval is equal and constant. So it is the regular ECG. P waves are round, upright and less than 0.10 seconds. So it is a normal P wave and it is followed by QRS complex, married to QRS complex. Coming to PR interval, we have 1, 2, 3, almost 3.5, 0.12 seconds. It is a normal PR interval. 3 to 5 is normal PR interval. Coming to QRS complexes, QRS complex has sharp angles and it is having almost 2 small boxes in it. So it is 0.08 seconds. Less than 3 small boxes in a QRS complex is a narrow QRS complex. So the interpretation of this ECG is also a sinus rhythm. Now let's solve this ECG. In this ECG, we have 1, 2, 3 large boxes, 300, 150, 100 and a little more than that. So we have a heart rate of 80 beats per minute. The RR interval is equal, constant, that is a regular ECG. Coming to the P waves are present and they are married to the QRS complexes. Looking at the PR interval, 1, 2, 3, 4, 4 small boxes. That's a normal PR interval, 4 to 5 small boxes. Looking at the QRS complexes, we have 1, 2, 1 small box, 1.5 small box. So it's a narrow QRS complex with sharp points, 0.12 seconds width. Interpretation is that it is a sinus rhythm. Now, this is a slightly difficult ECG, but the good thing is that they have already mentioned that which is the P wave, which one is the QRS complex, and which one is a T wave. Now, if you look at this ECG, let's calculate the heart rate. This is a QRS complex and this is another QRS complex. 1, 2, 3, 4, 4.5, 300, 150, 175 and slightly less than that. So it's almost in between 60 to 70 beats per minute. So that is a 65 beat per minute. Regularity, let's look at the distance between each QRS complex. It's almost equal. That's an RR interval. RR interval is equal, so that's a regular ECG. Looking at the P waves, they are round, they are upright, and 1, 2, they are of a normal size, they are present, they are married to the QRS complexes. Although this looks very ugly, but the things are going fine in this ECG. Let's go to the PR interval. PR interval 1, 2, 3, 4, 5. So we have almost 0.20 seconds. It's on the upper border, but the PR interval is also normal. Now let's look at the QRS complex. We have 1, 2 and 2.5. So it is 0.10 second. So it's also a sinus rhythm, a sinus ECG. Now pause this ECG and solve it yourself. Coming to the answers, let's calculate the heart rate. We have 1, 2, 3, 4, 5, 6, 7. So 300, 150, 100, 75, 60, 50, 45. So we have 45 beats per minute. Let's look at the RR interval. RR intervals are equal and this is a regular ECG. The P wave, this small squiggle that you see over here, this is a P wave. So P wave is present and it is married to the QRS complexes. Let's look at the PR interval. We have 1, 2, 3, 4 small boxes, 0.16 seconds. Let's look at the QRS complexes. QRS complexes are having almost 1 small box, 0.04 seconds. The interpretation is sinus bradycardia. This is a slow ECG. The rate is slow. Now pause this video and solve this ECG yourself. Coming to the answers, we have calculating the heart rate. We have 1, 2 large boxes, 300, 150 and slightly more than that. So it is 130 to 140 beats per minute. The RR interval is equal. So the ECG is regular. The P waves are present. These are the P waves and they are married to the QRS complexes. Looking at the PR interval, we have 1, 2, 3, almost 3 to 4, 0.12 seconds. Looking at the QRS complex, narrow, sharp angle, steep points. That's a normal QRS complex. And the interpretation is sinus tachycardia. The heart rate is very high. That is a sinus tachycardia. Now in these ECGs that I am teaching over here, these ECGs might be having many abnormalities in them, but right now we are not focusing on those abnormalities. Like in this ECG, you can see that there is a change in amplitude of QRS complex. There is a regular change in amplitude of QRS complex. We'll come to these details in the coming subsequent videos, but right now we are going to just practice the rhythm calculation, the heart rate, the P wave, the QRS complexes, and after that we are going to dive into the details of all these abnormalities and these heart conditions. Now let's calculate the heart rate between the QRS complexes. We have 1, 2 and more than 2. So this is 300, 150 and almost so 105 to 110 beats per minute is the heart rate. And if we look at the distance between the QRS complexes, the distance between the QRS complexes is equal. So it is a regular ECG. Let's look at the P waves. The P waves are present. These are the P waves and they are married to QRS complexes. These are the P waves. They are married to QRS complexes and they are present and they are married. Looking at the PR interval, let's calculate the PR interval. 1, 2, 3, 4, almost 4, 0.16 seconds. Let's look at the QRS complex. In the QRS complex, if we look, this is the start of QRS complex, this is the end of QRS complex. So it's 1, 2, 3, 4. So 0.16 seconds. Now, as I said, less than 3 small boxes is a narrow QRS complex. More than 3 or more than 3 small boxes is a wide QRS, which is abnormal. Now, the interpretation is sinus tachycardia, the heart rate is more than 100 with wide QRS complex. So there are many abnormalities in these, but right now we are just assessing the rhythms. We are just giving comment on the rhythm of the ECG. Now in this video, we mainly focused on the normal rhythms. We calculated the normal rhythms and very few of them were having abnormalities. Now after this, in the next video, I'll be talking about sinus arrhythmia, sinoatrial block, sinoatrial pause, sinoatrial arrest. I'll be talking about atrial fibrillation, atrial flutter, ventricular tachycardias, ventricular fibrillation. So if you have the basics, you can easily solve those ECGs. When you understand how to assess a QRS complex, how to calculate PR interval, how to calculate rate, how to look for the rhythm, only then can you understand those abnormal ECGs. And with those ECGs, I'll be briefly talking about their managements as well. So make sure that you watch the subsequent videos of this video series. Before going into the summary, please click on the subscribe button. We talked about what is P wave, the uniform, round, married to QRS complex, the PR interval, the normal PR interval, how to calculate PR interval, prolonged PR interval in first degree blocks, QRS complex, what is normal QRS complex, narrow, steep angle, sharp points, and then we solved many ECGs.